So, hello and welcome everyone to this particular session. I hope I'm live. Welcome back to this particular channel, Pradhan Academy. So, I welcome you again to this particular session where we are basically discussing on the JEE Mains previous year's questions, right? So, along with the sessions, we are also getting prepared for the JEE Mains second attempt, right? So, today I'm back again with another chapter on algebra portion. So, as of the last session is concerned, we have already discussed and finished up with binomial theorem. I hope you have all watched that particular session, okay? I hope there is no one who is coming to this particular session without watching the previous one, okay? So if you are someone who is new to this particular channel, I would request all of you to please go through the particular session that I have taken so far, and please try to practice those questions that I have taken up in the session covered, right? So if you look at the session that I have taken so far, you will see that I have already covered coordinate geometry and I have started with the algebra portion, right? So in algebra, we have already covered quadratic equations, binomial theorem, sequence series. Also, I discussed one part, that is logarithmic functions, right? So with this, our next chapter today is going to be discussing on complex number, right? So before we start on to discuss some of the previous year questions, let me tell you about the weightage of this particular chapter. So some of the statistical analysis gives me the result that in 2025, the weightage for this particular chapter was around 4%. Okay, that was around one question. Okay, one question. In every paper, you can see at least one question from complex number. And in 2023, if you look, it's again 1.2%, or it was basically around 3.3%. That's what my statistical results talks about. So that is again roughly around one question, right? And similarly, if you talk about 2022 paper, so you will find out the weightage was something about 3.7%, which is again roughly one question. And 2021, there was the weightage was around 3.72%, which was again roughly around one question. So as you can see, some from the statistical data that you can expect at least one question from complex number to be asked in your JEE Mains second attempt paper as well, right? So with this, we will discuss and start to discuss about the concept as well as the previous year questions along with this particular session. Okay, so if you are someone who is watching this session for the first time, I would request all of you to please hit the subscribe button and start watching the session with the initial part, right, from directly from the straight lines part. So you can definitely find all those sessions in the channel. So you can go under the live tab and you will find up all the video sessions that have been covered so far, right? And if you haven't joined the Telegram group, please join it now, so that the description or the link for the joining the Telegram group, you can find that up in the description box. Okay, so go to the description of this particular session, you will find out the Telegram channel link and join the link to get access to this particular channel content as well as lecture materials and many short notes as well as mock tests. Okay, so that will actually help out to get a good result and a good hold on your JEE Mains preparation. So with that, let's get started. And today our topic is going to be on complex number, right? So our goal is to discuss about the concepts of complex number, previous year questions, both MCQ and numerical type, and also we'll try to discuss about the paper statistics that I have already discussed about, right? So with this, let's get started on the very first problem for the JEE Mains previous year questions on the topic of complex numbers. So let's start solving the questions from here, right? So if you look at these questions over here, I would request all of you to, if you have discussed and completed the complex number part, I would give you some time to try for this question, okay? And if you haven't started discussing or started studying about the complex number, what my suggestion is basically, please try to read the NCERT textbook for the basics. And once you're done with that, please go through the NCERT exemplar problems. Okay, please go through the NCERT exemplar problems, and that will pretty much work in order to get a hold on the basics of the chapter. And once you get the basics, you can start to solve the previous year questions. Okay, that is what the roadmap or a kind of a guideline you can follow up. All right, so I hope this part is clear to all of you. Please let me know if we can start with solving this question. So let us proceed with solving this question over here. So as you can see, the question is talking about two complex number Z1 and Z2. And the complex number Z1 and Z2 are introduced in such a way that it is basically given in terms of a inequality. So let us try to understand what is this inequality talking about, right? So let me tell you about a very interesting locus, okay, that is circle, right? So if you recall that circle, so if we center of circle is origin or O, or maybe some point O, or let us call that point as A comma B, and then we take up any point, any variable point x comma y as P, such that this particular distance is always equal to R, then this PO distance is always equal to R, then this particular locus is called as circle, right? So that is, so if I need to write it down in terms of a complex number, I could easily do that in the Argand plane representation as, so let us talk about in the Argand plane. So I hope you know what is an Argand plane talking about. So it has the x-axis as a real part of z, and the imaginary part of z is given on the y-axis, right? And if I plot any variable z with a fixed z naught, and if I make this particular distance equal to some constant distance that is basically called as a radius of the circle, then the circle in will be written in terms of the complex number as z minus z naught mod is equals to R, right? So this mod is denoting the magnitude of the length between two complex numbers, and complex numbers in Argand plane are simply represented as points. All right. So I hope this part is clear to all of you, right? So if you look at the, so if you just try to look at from this question over here, we see that the expression is given as, z1 minus 8 plus 2 iota mod of it is less than or equals to 1, right? Now whenever this inequality, this particular quantity is nothing but it is a distance from z1 and the complex number 8 plus 2 iota. So it is talking about the distance from z1 and this particular complex number is such that it is less than or equals to 1. And so this is the first equation. So what is this particular equation talking about is that, so whenever I'm talking that distance is basically less than or equal to some quantity, then it is basically denoting the region which is inside the circle. So it is defining. So if I need to write it as z minus z naught mod is less than some distance, less than or equal to distance of d, so it is basically denoting the interior region of the circle. So it is denoting the interior region of circle with center as z naught and the radius is given as d. Right. So from this particular part, I can say that this is basically representing a circle, the interior point of a circle, which radius is 1 and the center is given as 8 comma 2 or 8 plus 2 iota as a complex number, right? So if we try to proceed with this question from here, so from here I can see that my z1, so let me try to plot them on the x and y axis, okay, or let me try to do some graphical analysis of that, right? So if we look at this first expression over here, it is talking about a circle with a origin at 8 comma 2. So 8 comma 2 will be something over here, right? And the circle will have a radius 1 over here. And similarly if you look at the second expression, it is basically given as z2 minus 2 minus 6 iota mod of it is less than or equals to 2. That is what is mentioned in the second expression, right? So that is basically talking about that our z2 is basically the some interior point of a circle whose center is given as 2 comma minus 6. So 2 comma minus 6 will be something over here, and the radius will be something less is 2, right? So that is basically it is touching the y-axis. So it will definitely touch the y-axis over here, something like this. Okay, that is basically 2 comma, that is basically given as 2 comma minus of 6, right? So I hope this part is clear to all of you, right? Now it is said you have to find the minimum value of z1 minus z2, right? So in order to find for the minimum value of z1 minus z2, now I know that the shortest distance will always occur. So this is a very interesting and an important statement that you must know from the applications of derivative, that is our shortest distance, will will occur along the common normal, will always occur along the common normal. Okay, so therefore if this is a curve 1, the circle 1 or circle 2, the common normal will be a line passing through the center of these two circles like this, right? Now in order to find the minimum distance, if I have z1 lying here and z2 lying here, then this will be giving my minimum distance. And similarly, in order to find the maximum distance, our z2 should be lying on the diametrically opposite ends of the circles, and that will generate me the maximum possible distance, right? So with this part, you are basically able to find out that the minimum Now, I'm not talking much on the maximum possible distance because there's some restriction to it, right? But in the question, it is mentioned about we have to find for the minimum part, right? So this minimum will always occur along the common normal, that is line passing the center. And when this Z1 and Z2 are lying exactly on the surface of the circle, that is what you have to understand, right? So how we go with this solution is that let us call the center of the second circle as B and the center of the first circle as A. So from here, I can easily find what is AB distance as square root of 8 minus 2 whole square plus 2 minus of minus, that is plus of 6 whole square, and that is going to give me is equals to 10 units, right? So the center to center distance is going to give me 10 units, right? Now this Z1 and Z2 distance will be minimum, or Z1 minus Z2 bar, the minimum value will be equals to this AB minus this radius of first circle and the radius of second circle, and that is going to give me the answer as 7 units, right? The radius of the first circle is basically equals to 1 and the radius of the second circle is equal to 2. So that is going to generate me the answer as 7 units, which is the minimum value of the Z1 minus Z2. So I hope you are able to understand this question. This is a very simple problem where we are just utilizing the fact that we are basically able to plot this region on a graphical base, and once we are able to do that on the graphical, once we are able to represent that graphically, the answer is very simple and straightforward to us, right? I hope this is clear to all of you. Okay. So if you're enjoying these sessions, please consider subscribing to the particular channel, okay? And please don't forget to share these videos with your friends as well, okay? So that your friends can also collaborate with these sessions and they can also come up live and also participate in this question solutions. Alright, so with this, I hope this particular part is clear to all of you, okay? If you have any questions, you can please let me know in the live chat. Right, so if you are not able to understand any part, you can tell me, I will repeat it again, okay? So you can definitely tell me again. And if you have someone who is watching the session after the class is over, okay, then please mention your doubts in the comment section of this particular session, okay? I'll be going through your comment section. I will be very happy to answer your comments, okay? And please make sure that you join the Telegram channel so that I can also give you personal solutions as well, right? So if you want more personalized solutions, you can definitely join the Telegram session, okay? And if you like my teaching and you want to learn more from me, you can definitely contact the number that is present in the description box, okay? So you can definitely contact on this particular given number in the description box for one-to-one personalized tuitions, okay? So I hope that part is clear to all of you. So with this part, let's move for the next part of the question, okay? So the next question with us is on our screen, right? So I would request all of you to please try this question, because this question is a simple problem. You can solve it by having some idea of fundamentals about the theory of the equations, right? So as you can see, there is a quadratic equations with the coefficients are given as complex numbers, right? And it is said that now since the coefficients are complex numbers, the roots will be also complex roots, right? Now from here, if we look at the given quadratic equation, now this is a very simple problem that you can also find this problem in the NCERT textbook also, okay? Now this question, you can find that up in the NCERT as well, okay? So students who have basically followed the NCERT, they know the question, okay? So the given equation is given as x square minus 3 minus 2 iota times x minus 2 iota minus 2 is equals to 0, right? That is what is mentioned in the problem, where iota is basically given as square root of minus of 1, right? That is what is mentioned in the problem. And it is said that this particular equation has roots equals to alpha plus iota beta, and the second root is given as gamma plus iota delta. Those are the two roots which are mentioned in the problem as given, right? Okay, now we need to find out the roots for this particular quadratic equation. So what I'm simply going to use, the quadratic formula. So using the formula, so the analytical formula that I know for it is basically this x1 and x2 are the roots. So this can be simplified as, so the formula is basically given as minus of b plus or minus square root of b square minus 4ac divided by 2a, right? So if I just apply this simple formula over here, it is going to give me 3 minus 2 iota plus or minus square root of 3 minus 2 iota whole square minus 4 times of, so minus of minus will get plus 4 times of 2 iota minus of 2, that is what, and divided by 2, that is what you will have as the roots as constant, right? which you can simplify it out and find it as, so our roots will be found out as x as simply as 3 minus 2 iota plus or minus square root of, now I can expand the 3 minus 2 iota square as 9 minus 4 minus 12 iota, and this part and the part that is multiplied, so this is going to be 8 iota minus of, so that is going to be 8 iota minus of 8, right, which is going to be the this square under the square root terms, right, and divided by 2, right, over here. So we can simplify this part as 3 minus 2 iota plus or minus the square root of going to be minus of 3 minus of 4 iota divided by 2. Now the interesting part to solve for this particular problem is to basically find out the square root of this particular complex number, right. Now square root of a complex number is always a complex number, so what I would suggest is that what you can do in order to find the square root of a complex number is to assume a complex number a plus iota beta and take the square of both the sides. So if you take the square of both the sides, it is something going to be like this fashion, right, and then you simply compare the real part with the real part over here and the complex imaginary part with the imaginary part of the complex number. That is what I would suggest to do over here. But since many students can directly do this part over here, so what I would tell them to do is that we can write this part as 3 minus 2 iota plus or minus, on this part you can obviously write this as square root of 1 square plus 2 iota square plus 2 iota minus of 2 into 1 into 2 iota, right. So if you do this calculation, you will get it as 3 minus 4 iota, right, and this is divided by 2. So this is going to yield me the result as 3 minus 2 iota plus or minus, and this is going to be equals to 1 minus 2 iota whole square, and square root of that will definitely give me this answer and divided by 2, right. So from here my two roots are going to be simply 2 minus 2 iota, and the other root is going to be 1 plus 0 iota, right. So from here you can see this is going to be alpha plus beta iota, and this is going to be gamma plus delta iota. So from here you can see that if you need to find out for this value of alpha into gamma plus beta into delta, and that is going to be, so alpha over here I'm having a 2, beta I'm having it as minus of 2, and I am having gamma as 1 and delta as 0. So from this if I just calculate it out, so it is going to be equal to 2. That is our option number A from this particular given question, right. So this given question has the answer as option A. I hope this is clear to all of you, right. So the answer to this particular problem is going to be option A, which is a very simple problem and straightforward. So if you just look at this problem, we are just doing the simple quadratic equation formula, and from that formula I'm basically trying to find out the roots and compare the roots with the given form over here. That's what the question is demanding of, right. So this is a very straightforward NCERT based question. Okay, so if you just practice the NCERT, at least you can see that at least you can solve one question that can be asked in the paper. All right, so that is, you can be very sure about it. Okay, so please let me know if you have any questions. Hi Sai Samrat. Yeah, we are basically discussing this for JEE Mains for the time being. Okay, for this part we are basically discussing for JEE Mains. Okay, these are all the JEE Mains previous year questions. These are all the JEE Mains previous year questions. Okay, Sai. Is it okay, Sai? So if you are enjoying watching this session, please consider subscribing, Sai. Okay, and you can always refer to your friends as well, so that they can also come up and participate in this discussion of the solutions. Okay, and that will be a healthy competition also to understand how is the preparation going along with your friends, right, and you will be having some confidence as well. All right, so please subscribe to the particular channel. Yes, Sai, you can tell me what is the question. All right, is this clear, Sai? So let's proceed with the next problem then. Now next problem is an interesting problem, right. Now it is about the geometrical representation of a complex numbers, right. So if we try to look at this particular problem, the problem is talking about that let O be the origin and the point A be Z1, such that Z1 is given as a complex number root 3 plus 2 root 2 iota, and the point B is given as Z2 such that root 3 times of Z2 mod is equals to Z1 mod, and it is also given in terms of argument that argument of Z2 is equals to argument of Z1 plus pi by 6. That means the Z1 complex number and the Z2 complex number are just having an angle of pi by 6, right? So this particular part is talking about the angle between the two complex numbers, right? So let us try to see what this question is talking about. So we know that I can represent any complex number. For example, if I have a complex number as a plus iota beta iota b, so I can simply write that in the Argand plane, where the representation of the z in the Argand plane will be like a point a comma b, right? Where a represents the real part, b represents the imaginary part. As simple as that, right? Now, so it is mentioned that z1, it is mentioned that z1 over here is mentioned as root 3. So z1 over here is mentioned as root 3 comma 2 root 2, right? That is what is z1 mentioned as, right? And similarly, z1 is mentioned like this, and similarly the z2 is mentioned with an angle of pi by 6. Now you must have a question that this this pi by 6 is in the clockwise direction or anti-clockwise direction, right? That is a very genuine question. What you can understand from here is that, now if it is a plus sign, what you can consider, because generally the anti-clockwise rotation is considered as plus, so let us consider some z2 over here, right? Now it is also having lesser magnitude, something like this over here is going to be z2, right? So what I'm going to do over here is that, so what I can do now, I know that our argument of z2 minus argument of z1 is basically equals to pi upon 6, right? That is what is mentioned, right? Now next what I can do, I can simply use the property of the argument or the difference of the argument. I can simply write this as argument of z2 upon z1. Now that is given as pi upon 6. That is given as pi upon 6, right? Now one more thing is mentioned in the problem is that the mod of z2 is equals to 1 upon square root 3 times of mod of z1. That is what is mentioned in the problem, right? Now I'm just simply going to use the rotation theorem, and I'm going to write it as z2, and I can write z2 as z2 mod divided by z1 mod multiplied with z1 e to the power iota pi by 6, because the angle between z1 and z2 is given as pi by 6, right? So from here I can simply write z2 as z2 mod by z1 mod, which is basically given as 1 upon square root 3, and z1 is given as square root 3 plus 2 root 2 iota multiplied with e to the power this iota pi by 6, that is going to be cos pi by 6 plus iota sin pi by 6, right? Because you always know that e to the power I theta is equals to cos theta plus iota sin theta, right? So from this part this will be equal to root 3 plus iota and whole divided by, oh, all right, this is what you will have, right? Now if you just try to simplify this part out, so you are going to get z2 as, 3 minus 2 root 2 plus iota times of 2 root 6 plus root 3 divided by 2 root 3, right? That is what you will have it as z2, right? Now in the question, if you look at this, it is talking about that we have to comment on the points a, b and origin, and what is the triangle that is forming out of that, right? So if you just take z2 and let us see what is our distance z2 minus z1, right? So if you just try to see the distance of the z2 minus z1, it is nothing but mod of, so you just try to take the difference. So the difference is coming as 3 plus 2 root 2 plus iota times of 2 root 6 minus root 3 whole divided by 2 root 3, and I will take the mod of it. So if you just take the mod of it, it is going to be simply equals to, now, and also this particular part is nothing but, this particular inside the bracket, the mod part is nothing but z2 conjugate. So z2 conjugate, right? So this mod is same as a z2 conjugate, and which mod is basically also same as z2, right? So mod of z2 conjugate is same as mod of z2. So what you can see that this particular difference, or the difference of the side, that is the AB distance is equal to OB distance, right? So whenever two sides of a triangle are equal, then it is a isosceles triangle. So that is what we can comment on the question, that is it is basically an isosceles triangle, right? So, and one of the angle is pi by 6. So what I can have, the other angle can also be pi by 6, because two angles in isosceles triangles are common. So other angle is pi by 6, then the third angle I will have it as 2 pi by 3, right? 2 pi by 3. So that basically gives you the implication that it is basically an obtuse angled isosceles triangle. From this you will be easily getting up the answer as option number D. which is the correct answer for this particular solution or this particular question. I hope the solution is clear to all of you. So what I'm getting, I'm basically getting this AB distance. So let us call this A, this B. So this AB distance is basically equals to OB, right? So this particular angle and this particular angle are basically same. This particular angle is given as pi by 6. So this should be also pi by 6. So from the sum of the angles and triangle is 180. So this particular angle is going to be 2 pi by 3, which basically means that this particular triangle OAB is basically going to be an obtuse triangle, because one of the angle is an obtuse angle, right? So it is going to be an obtuse angle isosceles triangle. I hope this is clear to all of you. Please let me know if this is clear or not. Please let me know if this is clear or not. If this is clear, please give me a thumbs up. Okay, we can proceed with the next problem. I hope you are able to understand the question. Okay, so we are just simply using the rotation theorem. Okay, so this argument, whenever you see an argument basically talks about the angle. Okay, so if I need to find out the argument of this particular complex number, the argument of a complex number is defined as tan inverse of B upon A, right? And if you have to talk about the principal argument, so the principal argument will always lie between minus pi to pi, where pi is included and minus pi is not included, open minus pi to pi closed. Okay, that is what you will have as the principal range of the argument of any complex number. I hope this is clear to all of you. I hope this part is clear to all of you. Please let me know if it's clear or not. Okay, so this part is clear. So if this part is clear, let us proceed with the next problem. Okay, so the next problem is again very interesting problem. Now this is going to be a interesting problem because if you see the expression that are given are very ugly or odd, right? But still we have to basically find out an integral solution out of that value, right? So how we are going to do that, let us try to understand. Okay, so it is saying that alpha beta are the two roots of the given equation. Okay, and we have a quadratic equation given as, so our given equation is given as 2 times of z square minus 3z minus of 2 iota. That particular part is equals to 0, right? And our iota is given as square root of minus of 1. That is what is mentioned in the problem, right? And it is said that alpha and beta are the roots of this equation, roots of this particular equation. Okay, they are the roots of this equation, right? Now interestingly, if you just try to look at this particular problem, what I'm going to do over here is that if I take 2 as common, it is going to be simply as z squared minus iota, and I can always equate that with 3 times of z, right? And further I can simplify this as 2 times of z minus iota by z, that is equal to 3. That is equal to 3, right? Now interestingly, we'll observe it as that is z minus iota by z, that is the equation that is given as equal to 3 by 2, right? So this equation, the z is equal to alpha and beta are the two solution, right? So for this particular equation, the roots are alpha and beta. The roots are alpha and beta, right? So from here, what I can do, I can always satisfy alpha and beta. So alpha, if I satisfy, it is going to be alpha minus iota alpha is equals to 3 upon 2. Right, now which I can further write it as alpha square minus 1 upon alpha minus 2 iota. So if I'm just simply taking the square on both the side, is equals to 9 upon 4, is equals to 9 upon 4 if I just take the square on both the sides, right? Now if I just try to simplify it further, I'm going to have it as 9 upon 4 plus 2 iota. 9 upon 4 plus 2 iota is simply as alpha square minus 1 upon alpha square. Right, now I can further take a square on both the side, and that will give me 81 upon 16 minus 4 plus of 9 iota, and that is going to be simply equal to alpha to the power 4 plus 1 by alpha to the power 4 minus of 2 over here, right? And if I take this minus 2 on this particular side, this particular minus 2, then we are going to have the value of alpha to the power 4 plus 1 upon alpha to the power 4 as equals to 49 upon 16 plus 9 iota. That is what we will have it over here, right? And similarly, if you just substitute for beta, you will also have the similar expression, that is beta to the power 4 plus 1 upon beta to the power 4. You will have it as 49 upon 16 plus 9 times of iota. That is what you will have, right? Now Now, if you just try to look at this expression over here, that is what you have to find out for. So if you just look at this expression, I'm just trying to simplify this expression in terms of the known quantities of like this, right? So what I can do from here is that, so if you just try to look at this expression, the first expression, that is alpha to the power 19 plus beta to the power 19 plus alpha to the power 11 plus beta to the power 11 divided by alpha to the power 15 plus beta to the power 15. So I can always take this as, so if I take alpha to the power 15 common, so alpha to the power 15 is common, it is going to be alpha to the power 4 plus 1 upon alpha to the power 4 plus beta to the power 15. If I take common, then it is going to be beta to the power 4 plus 1 upon beta to the power 4 and whole divided by alpha to the power 15 plus beta to the power 15. So what if I take this beta to the power 15 and alpha to the power 15 as common? This particular part is going to simply cancel out, and we are left out with alpha to the power 14 plus 1 upon alpha to the power 14 plus beta to the power 4 plus 1 upon beta to the power 4. That is simply going to be just twice of this particular result, right? So that is what we will have it over here as, and for the first part we have to only find the real part. So the real part of that, so real part of that particular part is going to be equal to simply the real part of this, right, multiplied with 2, right? Okay, so from here you will see that the sorry, these two values are common, right? Sorry, not multiplied by 2, it's simply just going to be 49 upon 16, right? And similarly, if we need to find out that this particular expression and the imaginary part of the expression, it is just going to be equal to 9. So if I need to find the imaginary part of that particular expression, it is going to be equal to 9, right? And ultimately we have to report the value of this particular product, that is 16 times the real part, that is going to be 49 upon 16, and this part is going to be 9. So the 16 and the 16 going to cancel out, and ultimately your answer is going to be 49 into 9, and that is what is equals to 441, or option number A, which is the correct answer to this particular question. I hope this solution is clear to all of you, right? This was a very interesting problem. Just you have to do some mathematical jugglery in order to solve for the correct expressions. Okay, I hope this is clear to all of you. I hope this part is clear to all of you. Please let me know if this part is clear or not. Okay, I will repeat it again. Fine. So let us proceed with the next part. So I hope this part is clear. So then we can proceed the next part over here, right? So if you just look at the next parts, so please let me know if you have any questions. Otherwise, I will proceed. Fine. So, all right. So this part is clear to all of you, I hope. So even if you have any slightest of a question or a doubt, you can definitely comment out. Okay. And don't forget to join the Telegram channel. Okay. I will discuss the solutions also in the Telegram channel if you have any specific questions which you are not able to solve it. Okay. All right. So with this, let's proceed with the next part. So let us proceed with the next part of the question. Okay. So this is our next question which we have with us. Is a very interesting problem from the JEE Mains previous year questions. Okay. Very straightforward question, just understanding the concept. That's it. So it said that you have to find out the number of solutions for the Z, or the number of complex number that is satisfying this particular criteria, that is mod of Z is equals to 1. That is the complex number with unit magnitude, and also satisfying another relation, that is Z upon Z bar plus Z bar upon Z is equal, and mod of that is equals to 1. Right? That is what we have to find out for. So since this complex number is having unit modulus, so I can assume this Z as e to the power iota theta, e to the power iota theta, as simple as that, right? Then my z by z bar is going to be equal to e to the power iota theta divided by e to the power minus of iota theta, which is going to be equal to e to the power 2 iota theta, which is simply going to be e to the power 2 iota theta, right? Now, and similarly the part of z bar upon z is simply going to be e to the power minus of 2 iota theta, right? And it is also said that z upon z bar plus z bar upon z mod of that is equals to 1, which you can simplify as part is that e to the power 2 iota theta plus e to the power minus 2 iota theta mod of it is equals to 1, right? Now from here what you can do is that you can simplify in terms of, so this part will give you the result as cos of 2 theta plus iota sine 2 theta, right, plus cos of 2 theta minus iota sine 2 theta and that particular mod is going to be equals to 1, right? That is what is mentioned. So you can see this minus iota sine theta and minus iota plus iota sine 2 theta is going to cancel out, and simply the result is basically 2 times of cos of 2 theta mod of it is equals to 1, right? And from here you will also get the part as cos of 2 theta mod of it is equals to 1 upon 2. So now if you need to find out the number of solutions for this z, right? Now what I'm going to assume is that now we have to find out a number of complex number which is satisfying this, right? And whenever we talk about the Argand plane, it is basically this 0 to 2 pi, right? So we have to basically find out for the solution in between 0 to 2 pi, right? And now this is basically a question of trigonometric equations, right? So we just need to find the graph of it. So mod of cos 2 theta, so that is going to be looking like this. Okay, so like this over here, as simple as that. And from here to find out the number of solution in 0 to 1 by 2, and from here, so you just need to change it. So since this is cos of 2 theta, so remember this is going to be equal to pi by 4, this is going to be equal to pi by 2. Please correct me if I'm wrong anywhere. Okay, this is going to be 3 pi by 2, right? Or 3 pi by 4, I guess. So this is going to be 3 pi by 4, and similarly there is 1. So we have to go till now here. This theta is basically this particular theta is basically between 0 to 2 pi, right? So if you just try to find out the number of solutions from this intersection points, you'll find out that in between 0 to 2 pi, for this particular solution, you will have 8 solutions. Okay, you will have 8 solutions, which is very obvious from the graph. Okay, now I'm not able to draw the graph completely over here because of the lack of space. So what I would suggest is please try to draw this graph completely, okay, with the complete marking from 0 to going up to 2 pi. Okay, 0 to going up to 2 pi. Okay, so somewhere over here you will have another, this particular length is basically of the pi length, right? So somewhere over here, again, if you just, it will have been 7 pi by 4, and then it is somewhere over here where you have to end up as 2 pi, right? That is what you have to do. So from here you can see that there are 8 solutions, 1, 2, 3, 4, 5, 6, right? And I hope I'm not missing out any one solution. So you can try to do this part by yourself, okay, and you can find out that the number of solution will be simply equals to 8. So from this part, just let me check it again. Actually, what I'm getting is a 6 only, okay, right? Yeah, fine. I'm only getting 6 solutions, right? So that is not going to be 8 solution. It is going to be only 6 solutions, okay? Pardon me. It is going to be only 6 solutions, okay? So you can, it is obvious from the graph over here, right? So we just need to solve for this trigonometric inequality, and once you solve for this trigonometric, equality, then you have to find out the number of point of intersection of this particular curve with the straight line y equals to 1 by 2. And from that you will see that there are 6 solutions that is existing, right? So with this you will be having option number D as our correct solution to this particular answer, right? So I hope you are all getting option D as your correct answer. Please let me know if you are not having any issue or anything. You can always have a question, okay? Don't worry, I will be going through your live chats and I will be answering each and every one of your queries, okay? So please let me know if you have any questions. Otherwise, we can proceed with the next problems, okay? So I hope this part is clear to all of you. Please let me know if this is clear or not. So generally, what you can expect in complex number is that, now more general, if I talk about, the questions are going to be very, very straightforward. The questions are generally of the type of given some equations in complex numbers, but to solve for that particular complex number by putting z equals to x plus iota y. Mostly those types of questions are very interesting and very important, especially for your JEE Mains, right? So if you are looking for practicing some kind of question, please try to focus more on the basics part, and also try to understand all the basic representation of the complex numbers, okay? That will actually help you to understand the question part as well, or in order to solve the question, that is going to be very, very important. I hope this is clear to all of you. So let us proceed with the next problem. So from this part, we will have the next question given as, The next question is talking about, that is, we have to given a relation, that is z bar minus iota divided by 2 times of z bar plus iota mod of it is given as equals to 1 upon 3, is given is simply equals to 1 upon 3, right? And it is said that z belongs to complex number. That is what is mentioned in the problem. And be the equation. Now this is going to be the equation of a circle with center. So it is a circle with center given as C. So it is a circle with the center C. Now it is said that if the area of the triangle whose vertices are the origin C and alpha comma 0 be 11 square units, then I have to comment on the unknown value alpha. Right. So that is what is mentioned in the problem over here. So let us try to solve for this question. Okay. So let us try to solve for this question. So if we just try to look at this expression over here, it is basically z bar minus iota divided by z bar plus iota by 2 mod of it is equals to 1 upon 3. And from this part, if you just try to simplify this z by putting it as x plus iota y, you will find it up as, so this is going to be 3 times of, so just multiplying it, 3 times of x minus, sorry, let me try to do the correct application. So very directly I'm just finding out the magnitude, that is going to be x squared plus y plus 1 whole square is equals to it is going to be so this is going to be a 2 times over here, right? So I've taken 2 common, so this is going to be 2 by 3, right? So that is going to be 2 times of x square plus y minus 1 upon 1/3 whole square of it, right? That is what my equations is looking like, right? Now I'm going to simply substitute or take the square on both the sides. So I will have it, the expression as 9 into x square plus, so this is basically, I forgot to write the square root part over here. I hope this part is clear. And then this part is going to be of this form, and it is equals to 4 times, and it is equals to 4 times x square plus y minus 1/3 whole square. I'm just taking simply square on both the sides, right? Now if I just try to expand it, I'm going to have the relations as 9x square plus 9y square plus 18y plus of 9 is equals to 4x square plus 4y square minus of 4y plus of 1, right? Which I can simplify it as 5x square plus 5y square plus 22y plus 8 is equals to 0, right? And from here I can simply get the equation of circle as x square plus y square plus 22 by 5 plus divided by y into y plus 8 by 5 is equals to 0. That is my general equation of the circle. So if I have a general equation circle, so I know the center of the circle is simply given as minus g comma f, that is going to be 0 comma minus of 11 by 5. That is my center of this circle, right? That is mentioned as C. Now in order to find the area of the triangle, so area of the triangle is given as half into mod of the determinant, that is 0 comma 0 comma 0 comma 1, that is 0 comma 0, that is the first point. So 0 0 1 0 0 1, the second end is going to be 0 minus 11 by 5 1, and the third is alpha 0 1. That is the determinant we need to find out, and this is given as 11 square units, right? So we just try to solve for this part. It is going to be equals to minus of 11 by 5 alpha and whole square of it is simply going to be equal to 22. So from this part we can just simplify it and get the value of alpha. So our alpha square from here is going to be equal to 100. It's going to be simply equal to 100. You can check it. Okay, it is simply going to be equal to 100. So from here we'll get the value of alpha square, that is asked in the problem, is going to be equal to 100. So that is my option number B, which is going to be the correct answer for this particular solution. Okay, I hope this particular question is clear to all of you. Please let me know if it is clear or not. I hope this part is clear to all of you, right? So this was just about calculation. So once you know the formula about calculating the area of a triangle from the given coordinates, we're basically very easy to solve for the area. And once we get the area, from that we can have to find out the value of the unknown, that is alpha. I hope this previous year question is simple and clear to all of you. Please let me know in the live chat. Exactly, Sai. Exactly, you are correct. Just cross multiply n square and put z equals to x plus iota y. Excellent, excellent. So from that we will have a circle equation, and that circle equation will give you all the required information, right? I hope this is clear to all of you, right? If you have any questions, you can definitely ask up, okay? Or else we can proceed. To the next problem. So next problem is again a very interesting problem. It is said that there is a curve that is mentioned as z into 1 plus iota plus z bar into 1 minus iota is equals to 4, and z is basically belonging to complex number. And it is said that the region z minus 3 mod is less than or equal to 1. Now this particular the curve is dividing this particular region into two halves, into two parts, right? One of the parts having area as alpha and one of the part is having area as beta, right? So then we have to find out what is the value of alpha minus beta. So this is more of a question of definite integral, what I will tell you, okay? So it's just a question between a curve and a particular or area between two curves, okay, as you can simply see. So that is what you have to try to find out from this particular problem, right? So if you just look in this particular first part of the graph, so what I'm going to do is simply just put x equals z equals x plus iota y, right? I just simply put z equals to x plus iota y, and if I solve the first equation from there, I will get it as x plus iota y multiplied with 1 plus iota 1 plus iota plus x minus iota y multiplied with 1 minus iota is equals to 4, right? And if you just try to simplify it further, I'm going to get it as x plus iota x plus iota y minus y plus of x is equals to, or sorry, minus of iota x minus of iota y minus of y is equals to 4, right? Now this part you can simplify it out, I can see that this part and this part get cancelled, this part also get cancelled. So ultimately you are left out with 2 times of x minus y is equals to 4, which is basically equal to x minus y equals to 2. That's a straight line, right? So the first equation is talking about straight line and second equation is a circle. So what I can simply draw it, so circle with the center 3, 0, right, with a radius is equals to 1, and it is talking about the interior region, right? This is going to be 2, 0 and this is going to be 4, 0, and the straight line that is basically something like this, okay? So it is basically passing through 3, 1 and 2, 0, right? So it is basically time to talk about that this particular curve, this is the first curve, right? This is the first curve, or the curve that is basically mentioned in the first the equality, right? So this curve is dividing this particular area into two regions, right? So as you can see, this is dividing this curve in this particular region into two areas. One is the yellow part and one is the blue part, okay? So let us call this alpha, this is beta. So from here, so I can simplify beta as just by integration, okay? Or what you can also do is that, so you can simply go for this area under the curve by simply integration, right? Integration from the x limit, that is 2 to 3, and the difference of these two curve, that is basically this curve is basically the circle, that is circle equation with the center. Circle equation with center will be something like this, which is equals to 1. So from here we will have y is equals to 1 minus x minus 3 whole square and square root of it, right? So it is going to be square root of 1 minus x minus 3 whole square dx, right? Dx, sorry, I should also take the separation part as well. So minus this particular curve, which is the equation, the simple equation of that particular curve is basically y equals to, so it is basically y is equals to, this is a straight line, which equation is y is equals to x minus 2. So that is going to be x minus 2, and you have to take the integral of this, that is going to be beta, and once you find beta, alpha is simply going to be the area of the circle minus this beta, right? So area of the circle is going to be pi upon, so the area of the circle is going to be simply equal to pi, because radius is 1, right? So pi minus beta, that is going to be your alpha, right? But if you don't want to do it in this way, another very simple way is to basically find this entire area, find this part of the area of the circle, right? This part of the area of the circle, and then add the area of triangle. So our alpha is going to be 3 by 4 pi as the area of this 3/4 of the circle plus this particular triangle, which is basically going to be this 1 and this is also 1, which is going to be 1 upon 2. That is going to be alpha. And your beta is going to be the remaining part, that is pi minus this part, that is going to be pi by 4 minus of 1 by 2. So from here, your alpha minus beta is equals to pi by 2 plus 1. That is the value of this alpha minus beta. Okay, so your alpha minus beta mod, we take the absolute value, so that is basically going to be the difference, or the difference of this absolute value, the area, which is coming out as pi by 4 plus pi by 2 plus 1. So from here you can see that option number D is going to be the correct answer for this particular problem. I hope this is clear to all of you, right? So with this, we are almost done with solving the important previous year questions for the JEE Mains part, right? I hope this part is clear to all of you. So with this, I am leaving one question as a homework to all of you. Okay, now this is the homework problem. Please try to solve this homework problem and let me know the answer in the comment section. Okay, I will looking for your answers in the comments. So please let me know in the comments, and for the solution, please stay tuned to join the Telegram channel. Okay, join the Telegram channel. I hope this is clear to all of you, right? So with this, we are almost done solving the important questions from the complex number part, right? So I hope this is clear to all of you. If you have any slight of a question, you can definitely put that up in the comment sections as well. All right. So with this, let us end our session over here. I hope you have enjoyed the session. And if you did enjoy the session, please don't forget to hit the like button and subscribe to the particular channel if you are new over here. And please make sure that you watch the previous content as well in order to prepare or revise for the JEE Mains previous year questions. All right. So with that will actually help up in order to revise the entire part for your maths portion for your second attempt. So with this, I wish you all the best and thank you.